Tobias Harlan stood outside his cabin in the bitter cold of January 1841, running his bare hand along the dry, solid logs, while his neighbor, Ezra Caldwell, shivered inside his own cabin just 200 yards away, scraping black mold off walls that wept with condensation. What separated their two structures was a single decision Tobias had made 18 months earlier that every other trapper in the Montana Territory had called the stupidest waste of effort they'd ever seen. Before we dive in, let us know where you're watching from, and if stories of forgotten frontier wisdom move you, hit that subscribe button, because tomorrow's episode reveals an innovation even more unbelievable than this one. The sound that woke Tobias Harlan on the morning of October 12, 1839, was not the crack of rifle fire or the roar of a grizzly. It was the deep, splintering groan of wood giving way under weight it should have easily supported. He sat up in his bedroll, listening. The sound had come from the direction of Jacob Reinhardt's cabin, 200 yards east through the pine forest along Beaver Creek, in what would later become southwestern Montana Territory. Tobias pulled on his boots and grabbed his rifle. Dawn was just breaking, and frost covered everything in a thin white layer. He moved quickly through the trees, his breath visible in the cold air. When Jacob's cabin came into view, Tobias stopped. The structure looked wrong. The roof line sagged on the north side, and as he watched, another groaning crack echoed through the morning silence. Jacob burst through the cabin door, stumbling into the clearing in his long underwear, carrying an armload of supplies. His face was white with panic. Behind him, the cabin's north wall was visibly bowing inward. Tobias ran forward, helping Jacob move away from the structure. They had barely cleared 20 feet when the roof beam on the damaged side gave way completely. It didn't collapse dramatically. Instead, it punched through the weakened wall logs like a fist through rotted paper, tearing a gaping hole in the side of the cabin and bringing down a section of roof with it. The two men stood in silence, watching debris settle. Jacob's cabin had been built just 14 months earlier, in August of 1838. Tobias had helped with the construction. They had used sound logs, notched the corners properly, and chinked every gap with moss and mud mixed with clay from the creek bank. The cabin had seemed solid and well built by every standard both men knew. Jacob was shaking, though whether from cold or shock Tobias couldn't tell. They salvaged what they could from the damaged cabin over the next hour. Most of Jacob's supplies were intact, but the structure itself was finished. As they worked, Tobias examined the broken wall logs carefully. What he saw disturbed him deeply. The logs weren't just broken. They were rotted. The wood that should have been solid and strong after barely a year was soft and black with decay. When Tobias pressed his thumb into one of the exposed log ends, it sank into the wood like pushing into wet earth. The rot extended deep into each log, spreading from the interior surfaces outward. The outer bark and the outer inch of wood appeared normal, but beneath that protective layer, the logs had deteriorated with shocking speed. Jacob stood beside him, staring at the damage. "I built it right," he said quietly. "We both know I built it right?" Tobias nodded slowly. Jacob had built it right by every rule both men knew. But clearly, something they thought they understood about cabin construction was wrong. Winter arrived early that year. By November of 1839, snow covered the Montana high country, and temperatures dropped well below freezing most nights. Jacob Reinhardt moved into a shelter he built quickly, using salvaged materials and help from neighboring trappers. Tobias returned to his own cabin, but he couldn't stop thinking about those rotted logs. He had seen cabins fail before. Mountain winters were harsh, and structures took damage from snow load, wind, and simple weathering. But he had never seen rot develop that quickly or that severely. Jacob's cabin had stood for barely 14 months. The logs had been freshly cut, properly dried, and well constructed, yet they had rotted from the inside out as if they had been standing for a decade. Tobias began paying attention to other cabins in the area. The trapping community along this section of Beaver Creek and its tributaries was small and scattered, but within a day's travel, there were perhaps 15 occupied cabins and twice that many abandoned structures. Over the next 3 months, Tobias visited everyone he could reach. The pattern he discovered was consistent and disturbing. Cabins that had been most carefully sealed showed the worst decay. Structures where trappers had meticulously chinked every gap, packed every crack with moss and mud, and sealed every potential opening were rotting faster than cabins built with less care. It made no sense by conventional understanding, but the evidence was undeniable. Tobias talked to every trapper he encountered that winter. He asked about their cabins, about problems they had noticed, about repairs they had needed to make. Most men didn't think much about it. Cabins needed maintenance. Wood deteriorated. That was simply how things worked on the frontier. But when Tobias asked specific questions, a picture emerged. Experienced trappers mentioned that their cabins felt damp inside during winter. They described water dripping from roof poles on cold mornings. They talked about bedding that never quite dried out, about black spots appearing on interior walls, about a musty smell that developed in well-sealed cabins after the first hard freeze. These details were accepted as normal, unpleasant, but unavoidable aspects of winter living in a log structure. Tobias examined his own cabin with new attention. It was a standard structure built 3 years earlier using methods he had learned in Kentucky. On cold mornings, he noticed condensation forming on the interior surface of the logs. When warm air from his fire met the cold wood, moisture appeared as if the logs were sweating. He had always assumed this was normal. Now he wondered if it was the beginning of the rot that had destroyed Jacob's cabin. He began a simple experiment. Each morning, he wiped condensation from a section of interior wall and examined the logs carefully. Within 2 weeks, he noticed the wood in that area felt slightly softer than surrounding areas. The moisture was soaking in, and the wood was beginning to deteriorate. He was watching the rot develop in real time. Tobias realized something that winter that would change everything. The problem wasn't outside the cabin, it was inside. Spring of 1840 brought thaw to the high country. By late April, trappers were finishing their winter work and preparing for the journey to trading posts to sell their furs. Tobias had spent the winter thinking about cabin construction and moisture, and he had developed a theory that seemed both obvious and radical. Wood needed to breathe. Moisture needed somewhere to go. Sealing a cabin completely trapped moisture inside, where it destroyed the very logs meant to protect you. He shared his thinking with Jacob Reinhardt first. They sat outside Jacob's rebuilt shelter on a warm afternoon in early May. Tobias explained what he had observed, the pattern of rot in sealed cabins, the condensation problem, the need for ventilation. Jacob listened politely, then shook his head. "You want to leave gaps in the walls on purpose?" Jacob asked. "Tobias, that makes no sense. The whole point of chinking is to keep weather out and warmth in. If I leave gaps, I might as well sleep under a tree." Tobias tried to explain about moisture and air circulation, about how trapped dampness was worse than a slight draft. But Jacob had already made up his mind. He was rebuilding his cabin using traditional methods, sealing every gap as tightly as possible. This time, he insisted, he would use better mud and pack it more carefully. The problem, Jacob believed, had been poor chinking, not too much chinking. Word of Tobias's theory spread through the small trapping community. The reaction was swift and unanimous. Every experienced trapper thought he was wrong. Ezra Caldwell, a veteran mountain man who had survived 15 winters in the Rockies, laughed openly when he heard about it. "Harlan's gone peculiar," Ezra told anyone who would listen. "Man spends too much time alone, starts thinking crazy thoughts. Leave gaps in your cabin walls? That's how you freeze to death, not how you stay warm." Duncan MacLeod, a Scottish trapper whose cabin was considered one of the best built in the region, was even more direct. He visited Tobias in late May specifically to talk him out of what Duncan called complete nonsense. "Lad, I've built cabins from the Highlands to the Rockies," Duncan said, his accent thick with exasperation. "Every builder knows you seal the structure tight. What you're proposing is wasteful, dangerous, and contrary to everything practical men have learned over centuries. You'll waste effort, waste materials, and likely die of cold for your trouble." Tobias listened to the criticism without arguing. He had expected resistance. What he was proposing contradicted everything these men believed about shelter and survival. He couldn't prove his theory through argument. He could only prove it through demonstration. By early June, when most trappers were heading east to sell their furs, Tobias had become a subject of humor around evening campfires. Men joked about Harlan's breathing cabin and speculated about how long he would survive his first winter in a structure deliberately built with holes in the walls. The consensus was clear. Tobias Harlan had lost his mind, and his foolish experiment would likely kill him. Tobias left for St. Louis in mid-June of 1840. The journey took 3 weeks on horseback, following established trails through territory that was becoming increasingly traveled as the fur trade reached its final years. He sold his winter's catch of beaver pelts for a modest profit, enough to sustain him and fund his construction plans. Most trappers who came to St. Louis spent their money quickly on whiskey, gambling, and entertainment before returning to the mountains as poor as they had arrived. Tobias spent his time differently. He walked the streets studying buildings, talking to carpenters, and watching construction crews work on warehouses and homes. He was looking for answers to specific questions about moisture, ventilation, and wood preservation. He found some answers in conversations with a German carpenter named Herschel, who was building a grain storage facility near the riverfront. Herschel explained that grain needed air circulation to prevent mold and rot. The warehouse was being built with deliberate ventilation gaps in the walls, spaces that allowed air to flow through while still protecting the grain from rain and direct weather. The principle, Herschel explained, was simple. Moving air prevented moisture accumulation. Trapped air created dampness, and dampness created decay. Tobias spent 2 days watching Herschel work, studying how the ventilation system was constructed, how gaps were positioned and protected. The techniques weren't directly applicable to a log cabin in the wilderness, but the underlying physics was identical. Air needed to move, moisture needed to escape. When Tobias returned to the mountains in late July, his pack horses carried unusual cargo. He had 40 pounds of oakum, a fiber material used for caulking ships. He had purchased 3 dozen wooden wedges of specific dimensions, each shaped to create precise spacing. He had brought canvas treated with linseed, oil, copper wire for binding materials together, and a specialized draw knife designed for fine shaping work. He had also brought 2 books, one about building construction and another about moisture and wood preservation, both of which he had convinced a bookshop owner to sell him despite his rough appearance. When other trappers saw what Tobias had hauled back into the mountains, the mockery intensified. Ezra Caldwell examined the wooden wedges and couldn't understand their purpose. "You hauled spacing blocks 3 weeks through the wilderness? For what possible reason?" Duncan MacLeod looked at the oakum and canvas with clear disdain. "That's ship caulking material, lad. We're 1,000 miles from any ocean. What use is that in a mountain cabin?" Tobias didn't explain. He simply packed his supplies and headed to the location he had selected for his new cabin. The site was on high ground near Beaver Creek, with good drainage and clear sight lines. He began work in early August, working alone, following a construction plan that existed only in his head and in the notes he had been keeping throughout the winter. Other trappers occasionally rode by to watch his progress. They shook their heads at what they saw, convinced they were watching a man waste 3 months of effort on a cabin that would fail spectacularly when winter arrived. Tobias began with the foundation, something most trappers skipped entirely. He dug a shallow trench around the cabin's perimeter and filled it with stones gathered from the creek, creating a level base that would prevent settling. The work took 5 days. Neighboring trappers who saw it thought he was wasting time on unnecessary refinement. The logs he selected were chosen with obsessive care. He rejected trees with excessive taper or irregular growth. He wanted logs as uniform as possible, approximately 10 inches in diameter, straight and free from major knots. He spent 2 weeks cutting and hauling 30 logs from trees he had marked during his spring scouting. Each log was stripped completely of bark using his draw knife, then shaped to remove irregularities. The innovation began with the first log course. Instead of simply stacking logs directly on each other as traditional construction demanded, Tobias placed his wooden wedges at regular intervals along the top of each log before setting the next log in place. The wedges were precisely shaped, 3/4 of an inch thick, creating a consistent gap between each horizontal log course. To anyone watching, it looked insane. The gaps were visible, running the entire length of each wall between every log. Ezra Caldwell rode by during the second week of construction and sat on his horse, staring in disbelief. "Harlan, those gaps are big enough to stick your fingers through," Ezra said. "You planning to chink those, or are you just building a cabin the wind can blow straight through?" Tobias paused in his work. "I'm chinking them, but not the way you'd think." His chinking technique was unlike anything used in frontier construction. He took his oakum fiber and soaked it in a mixture he had prepared from pine resin, boiled down to a thick tar-like consistency. The treated oakum became flexible but strong, resistant to water and decay. He packed this material into the gaps between logs, but only on the outer 2/3 of each gap. The outer portion of each gap was sealed completely, creating a weather barrier that would stop rain and wind. But the inner 1/3 of each gap remained open, covered only by a strip of his oil-treated canvas tacked to the interior wall surface. The canvas was porous enough to allow air movement but tight enough to block drafts. The result was a wall that appeared properly sealed from the outside but had a hidden ventilation pathway on the inside. Warm, moist air from cooking, breathing, and body heat could migrate through the canvas, enter the interior gap space, and escape to the exterior through the oakum's fibrous structure before condensing on the wood surfaces. The system created constant, gentle air movement through the wall structure itself. Duncan MacLeod visited during the 3rd week and examined the work closely. "You're making it complicated for no reason, lad. Traditional chinking works fine if you do it properly." Tobias continued working, placing another wedge, setting another log. "Traditional chinking traps moisture," he said quietly. "This lets it escape." Duncan shook his head and rode away, certain he was watching elaborate foolishness. The corner construction required different treatment than the walls. Tobias understood that structural integrity depended on solid corner joints. He couldn't leave gaps where the logs interlocked. Instead, he used traditional saddle notch joints at the corners, cut precisely and fitted tightly. These corners would bear the cabin's weight and hold the structure rigid. The ventilation system worked in the long wall spans between corners, where gaps wouldn't compromise strength. Each wall section between corners became what Tobias thought of as a moisture pathway. The warm air inside the cabin would naturally rise and seek escape routes. His canvas-covered interior gaps provided those routes, allowing vapor pressure to push moist air into the wall cavity where it could dissipate through the outer oakum layer before condensing. The physics was simple. Moving air couldn't condense. Only still, trapped air created the damaging moisture accumulation he had observed in sealed cabins. The door and window frames required careful integration into the ventilation system. Tobias cut these openings after the walls reached full height, ensuring the structural logs around each opening remained solid and gap-free. He couldn't afford weakness around entry points, but immediately adjacent to the frames, he maintained his gap spacing system, ensuring air could circulate even near these critical areas. The roof construction incorporated ventilation principles that Tobias had learned from studying grain storage buildings in St. Louis. He built a traditional ridge-pole roof with split plank covering, but he added a crucial feature. At the peak where the roof poles met, he left a continuous gap running the length of the cabin, covered with a raised wooden cap that prevented rain entry while allowing air to escape. This roof vent created natural convection. Warm, moist air would rise to the cabin's highest point and exit through the peak, drawing fresh air through the wall ventilation gaps in a continuous circulation pattern. Over the split planks, he laid multiple overlapping layers of birch bark for waterproofing. On top of the bark, he spread a thin layer of clay, mixed with grass for additional weather protection and weight to hold everything in place. The roof was heavier than necessary by frontier standards, but it was solidly waterproof and incorporated ventilation that most mountain cabins lacked entirely. The interior fireplace placement was strategic. Tobias built it in the corner opposite the door, using stones gathered from the creek and clay mortar. The fireplace would create the warm air that drove the entire ventilation system. Heat would rise, carry moisture with it, and push that moisture-laden air toward the wall gaps and roof vent, where it could escape before condensing. By mid-October, after 10 weeks of work, the cabin was complete. It looked strange to anyone familiar with traditional construction. The visible gaps between logs on the interior created an unusual ribbed appearance. Neighbors who visited shook their heads at the complexity and effort invested in what they considered fundamentally flawed design. Tobias moved his supplies inside and prepared for winter, confident in his engineering, but aware that he was about to test a theory that everyone else believed would fail catastrophically. Winter arrived in early November of 1840 with heavy snow and plummeting temperatures. By mid-November, the Montana high country was locked in conditions that would persist until March. Tobias settled into his new cabin and began the daily routines of winter survival, maintaining his fire, checking trap lines when weather permitted, processing pelts, and conserving supplies. The first thing he noticed was the lack of condensation. On cold mornings when temperatures dropped below zero, Tobias would wake and examine his interior walls carefully. The log surfaces remained dry. There was no frost buildup, no water droplets forming where warm interior air met cold wood. He would press his hand against the logs and feel them cool but completely dry to the touch. In his old cabin, those same cold mornings had produced heavy condensation. Water would literally run down the interior walls as frost melted when the fire was rekindled. Bedding near the walls would feel damp. The air itself had a clammy quality that never quite dissipated. In the new cabin, the air felt drier, fresher, despite the structure being closed against the weather outside. The cabin was noticeably cooler than a traditionally sealed structure would have been. Tobias estimated the interior temperature stayed perhaps 5 to 8 degrees colder than a completely sealed cabin with the same fire. But it was a dry cold, comfortable, with proper clothing and bedding. More importantly, the temperature remained stable. There were no dramatic swings between overheated air near the fire and freezing air in the corners. The ventilation system created constant, gentle air movement that distributed heat more evenly throughout the space. By December, neighboring trappers began experiencing the problems Tobias had predicted. Ezra Caldwell mentioned during a brief encounter on the trap lines that his cabin walls were sweating something fierce during cold snaps. Duncan McLeod, when Tobias visited in late December, had black mold growing on the north wall of his cabin where condensation had been heaviest. Both men accepted these conditions as normal winter challenges. Tobias said nothing about his own cabin's performance. He had learned that trying to convince experienced men through argument was futile. Only demonstration would matter, and winter was providing that demonstration daily. January of 1841 brought extended periods of wet snow mixed with rain, followed by hard freezes. These conditions were ideal for creating condensation problems. Warm, humid air from melting snow and rain would infiltrate cabins, then condense violently when temperatures dropped. Tobias watched the weather carefully, knowing this would be the critical test of his system. His cabin remained dry throughout. The ventilation gaps allowed moisture-laden air to escape continuously. When he examined the exterior oakum chinking during a brief warm period, he could see frost crystals formed on the outer surface where moisture vapor had escaped and frozen. The system was working exactly as he had designed it to work. Moisture was leaving the cabin before it could condense on interior surfaces. Meanwhile, 200 yards away, Ezra Caldwell was scraping ice off his interior walls and wondering why his carefully sealed cabin felt like living inside a wet cave. William Jessup was 23 years old and in his second winter as a mountain trapper. He had built his cabin the previous summer with help from more experienced men, following their advice precisely. Every gap had been chinked with moss and mud. Every crack had been sealed with clay. The structure was tight and well built by every standard the frontier community recognized. By mid-January of 1841, Jessup's cabin was becoming uninhabitable. Black mold covered the interior walls in spreading patches. Condensation formed so heavily during cold nights that water literally dripped from the roof poles at dawn. His bedding never fully dried. His stored food supplies were developing mold. The air inside smelled of decay and dampness. He had tried everything he could think of, building bigger fires, opening the door briefly to air out the space, scraping mold off the walls. Nothing helped. The moisture problem was getting worse. On January 22nd, desperate and unsure what else to do, Jessup rode to Tobias Harlan's cabin. He had heard the stories about Harlan's strange construction methods, heard the jokes about gaps in the walls and wasted effort. But he had also heard something else. A comment from Duncan MacLeod, made almost reluctantly. Harlan's place doesn't seem to have the dampness problem the rest of us are fighting. Tobias was outside splitting firewood when Jessup arrived. The young trapper looked exhausted and frustrated. They exchanged brief greetings, and Tobias invited him inside. The difference was immediately apparent to Jessup. The air in Tobias's cabin felt dry and clean. There was no smell of mold or dampness. The interior walls showed no signs of condensation or frost buildup. Jessup stood in the center of the cabin looking around in confusion. "How is your place dry? My cabin is so damp I can barely stand to be inside. What are you doing differently?" Tobias explained the ventilation system. He showed Jessup the gaps between logs on the interior covered by canvas. He explained how the outer chinking sealed against weather while the inner gaps allowed moisture to escape. He walked Jessup through the physics, warm moist air rising, seeking escape routes, finding the gaps, dissipating before condensing. He showed him the roof vent that created convection and continuous air circulation. Jessup listened intently, occasionally asking questions. He touched the dry log surfaces, examined the canvas-covered gaps, studied the construction details. Finally, he asked the question that mattered most. "Will you help me rebuild my cabin using this method?" Tobias agreed. They would wait until spring when reconstruction would be practical, but Tobias would teach Jessup everything he had learned about moisture management and ventilation. In the meantime, Jessup could improve his current situation by cutting small ventilation holes in strategic locations and creating some air circulation. Word of Jessup's visit spread quickly through the small trapping community. By early February, other trappers began paying attention to something they had previously dismissed. Harlan's cabin, the one everyone had mocked, was the only structure in the area that wasn't fighting serious moisture problems. The useless gaps were proving to be the most useful innovation anyone had seen. Spring thaw came in late March of 1841. As temperatures warmed and snow melted, trappers began assessing winter damage to their cabins. The extent of deterioration was worse than most men had expected. Cabins that had seemed solid in autumn now showed alarming signs of decay. Ezra Caldwell discovered rot in 3 of his wall logs on the north side, where moisture accumulation had been heaviest. The logs would need replacement before next winter. Duncan MacLeod found that his carefully fitted corner joints had softened from constant dampness, creating gaps where tight seals had existed the previous fall. Jacob Reinhardt's rebuilt cabin, constructed with obsessive attention to sealing every possible opening, had black mold throughout the interior that required scraping and cleaning before the space would be habitable. Tobias's cabin showed no deterioration. The logs were as solid as the day he had set them in place. The interior walls were clean and dry. There was no mold, no rot, no structural weakening. After 6 months of harsh winter conditions, the cabin looked and felt nearly new. In mid-April, William Jessup began reconstruction of his cabin with Tobias's guidance. They tore down the existing structure and salvaged logs that were still sound. Tobias taught Jessup the spacing technique, the partial chinking method, the canvas installation process, and the roof ventilation system. The work took 4 weeks. Other trappers stopped by during construction to watch and ask questions. Ezra Caldwell visited 3 times. On his first visit, he watched silently. On his second visit, he asked how the oakum chinking was prepared. On his third visit, he brought a bottle of whiskey and sat with Tobias by the fire, asking detailed questions about gap spacing, canvas selection, and moisture physics. Finally, he said what he had come to say. "I was wrong about your method, Harlan. I've been building cabins for 20 years, and I thought I knew what worked. But my cabin is rotting after 2 winters, and yours looks like it'll stand for 20 years. I need to understand what you're doing." Tobias shared everything he knew. He wasn't trying to keep secrets or profit from his innovation. He simply wanted people to build cabins that would last and keep them dry. He explained his observations about moisture and condensation, his research in St. Louis, the physics behind ventilation. Ezra listened carefully, occasionally nodding as pieces fell into place in his understanding. Duncan MacLeod arrived in early May with similar questions. The Scottish trapper was more reluctant to admit he had been wrong, but the evidence was undeniable. "Your approach contradicts everything I learned, lad," Duncan said. "But it's working, and mine isn't. I need to know why." By June of 1841, 5 trappers in the immediate area were planning to rebuild or modify their cabins using Tobias's ventilation principles. The technique that had been mocked as Harlan's Folly was now being called breathing cabin construction, or drywall building. The useless gaps had become essential elements of proper frontier architecture. The summer of 1841 marked a turning point in cabin construction throughout the northern Rocky Mountain region. Trappers who had witnessed Tobias Harlan's success began incorporating ventilation principles into their own building projects. The specific methods varied based on available materials and individual skill levels, but the core concept remained consistent. Wood needed to breathe, and moisture needed pathways to escape before it could cause damage. William Jessup's rebuilt cabin performed exactly as Tobias had predicted. Through the winter of 1841 to 1842, Jessup experienced none of the condensation and mold problems that had plagued his first structure. He shared his experience with other trappers he encountered, spreading knowledge of the technique further across the territory. Duncan MacLeod modified his existing cabin rather than rebuilding completely. He cut ventilation channels in strategic locations and installed a roof vent similar to Tobias's design. The modifications reduced but didn't eliminate his moisture problems. He concluded that partial implementation provided partial benefits. Full redesign would be necessary for optimal results. Over the next decade, as word spread through the scattered mountain communities, the breathing cabin technique became standard practice among knowledgeable builders. Trappers, hunters, and early settlers who understood the moisture problem built structures incorporating ventilation gaps. Those who didn't understand simply copied the method because they had seen it work, even if they couldn't explain why. The technique saved cabins and likely saved lives. Structures that remained dry and solid through multiple winters provided reliable shelter during periods when failure would mean death from exposure. Exactly how many people survived because their cabins didn't rot is impossible to determine, but frontier records from the 1840s and 1850s include numerous references to dry-built or breathing wall cabins that outlasted traditionally constructed structures by decades. Tobias himself continued trapping through the winter of 1842 then left the mountains in the spring of 1843. The fur trade was collapsing as beaver populations declined and fashion preferences shifted away from felt hats. He traveled west to the Oregon Territory, purchased land in the Willamette Valley, and established a small farm. He married in 1845, started a family, and lived quietly, far from the wilderness that had shaped his innovation. He never promoted his cabin-building technique through any formal means. He never wrote about it or claimed credit. When settlers occasionally asked him about construction methods, he shared what he knew freely, just as he had shared with fellow trappers. The innovation spread because it solved a real problem, not because anyone marketed it. Tobias Harlan died in 1868 at the age of 54. His obituary in the Oregon Statesman newspaper mentioned his early years as a mountain trapper, but made no reference to his contribution to frontier architecture. By that time, ventilation gaps in log construction had become common enough that most builders didn't know the technique had an inventor. It was simply how knowledgeable people built cabins in regions where moisture and rot were concerns. The useless gaps had become invisible, incorporated into standard practice, their origin forgotten even as their function continued saving structures from decay across the mountain west.